Welcome to today's video. Today we're going to be focusing on making conclusions using the law of syllogism. We're going to show this mastery in class. We're actually going to create a short story tomorrow, so I will give you the rubric for that, and your goal should be to score at least a 10 out of 12 on that short story. Now, the first thing we want to talk about is Venn diagrams and conditional statements. If you look at the Venn diagram that's on the screen, it's not one that you're used to seeing. And we're going to see some more of these in geometry now. If we look at those Venn diagrams, we have days of the year. And if we look at that inside smaller circle, it says days in February. So there's February 4th, there's President's Day. There are plenty more. We're only listing a few. The bigger circle says days in winter. What you need to keep in mind with these Venn diagrams is this little circle here, because it is completely in the larger circle, that means every day in February is a day in winter. Now, if you look, we have New Year's, we have January 10th. Those are days that are also in winter, but they are not in February. So this tells me that little circle is inside the big circle. It is always included. A conditional statement is an if-then statement. So we're going to say, if a day is in February, then it is in winter. That's going to hold true every time because every day in February is the inside. Now, when we talk about conditionals, this is what we're calling our hypothesis, as a reminder, and this is your conclusion. Now, the other type of Venn diagrams that you will see are going to be the typical ones that you've done before, as two overlapping circles. When we talk days of the year, we have days in February and we have holidays. There are holidays that are not in February. There are also holidays that, or days in February, that are not holidays. So you need to make sure that we know that the middle is both parts. So in this case, the middle would be holidays in February. The only holiday we have in February is President's Day. So that would be in my overlap circle. Now, when we talk about the law of syllogism, it's one of two laws that we're going to learn. It is similar, almost identical to transitive reasoning. And I'm going to show you it in a conditional form first, and then I'm going to show you what it looks like in sentence form. So you're going to have three statements. You're going to have if P, then Q, if Q, then R, and then you're going to be given a statement. As long as it is statement P, your conclusion, if we talk about transitive, we need to get rid of the middleman. Well, if I look at my middleman here, I have Q and I have Q. As long as those two are the same, my conclusion is whatever R is, because those Q's cancel each other out. If I give statement R instead of statement P at the bottom, so if we had said statement R, then my conclusion is going to be invalid. We cannot go backwards when it comes to the law of syllogism. We can only go forwards. I'm trying to raise this up so some of you guys can see it. But again, we can only go forwards. If we can get rid of the middleman, we have to go forward. So it would have to say if P, then R. Now, if we look at some of our examples, if it continues to rain, then the soccer field will become sloppy. If the soccer field becomes sloppy, then the game will be canceled. So again, we want to look at our individual parts. If I highlight what's the same, I have the soccer field will become sloppy and the soccer field will become sloppy. Since those are the same, those two can cancel each other out. This is my P statement. This is my R. We're not worried about what's highlighted. They're gone because they are the same. If I look, if it continues to rain, well, if I look back at my P's and my R's, this is my R. Or excuse me, my P. So that means my conclusion can be my R. My conclusion is the game will be canceled. Anytime you can cancel out the middleman and you have P as your statement, your conclusion is R. Because we said P then R, it is a valid conclusion. If we look at example 2, if a bank robber steals the money, then the police will track him down. If the police track him down, then the robber will be arrested. So again, if I highlight what's the same, the police will track him down, and the police will track him down. Since those are the same, we're going to cross both of them off, and we're going to focus on our P and our R. Well, if I look at the statement that they give me, it says a bank robber got arrested. Well, if I look back at my P's and my R's, this is R. Again, we can't go backwards, so my conclusion is invalid. There is no conclusion. We cannot go backwards and say, oh, the bank robber must have stole the money. A bank robber can get arrested for stealing money. They can get arrested for stealing a candy bar. They can get arrested for hitting somebody. There are a multitude of reasons of why somebody can get arrested. It doesn't have to be because they stole money. So do not go backwards. Now, if we look at this one, if Nate is reading, then he is reading a magazine. If Nate is bored, then he's listening to music. Well, if I look, there's nothing here that is the same. So it is an invalid conclusion, and there is no conclusion. If there is nothing that is the same, we cannot cancel anything out. We can't use the law of syllogism. We can't say that he's listening to music because it says if he's bored, then he's listening to music. We don't know. It doesn't cancel out. We can't use the law of syllogism. The last one. If a number is a whole number, then it is an integer. If the number is an integer, then it's a rational number. So again, I'm going to highlight what's the same. If it's an integer, since those are the same, we're going to cross them out, and we're left with P and R. So now we have to look. My statement says the number is 18. Well, if I look at my statements, it says if a number is a whole number, then it's rational. What you have to ask yourself, is 18 a whole number? Because I want it to be P. So if it's P, is 18 a whole number? Well, yes, it is a whole number, so that makes P true. If P is true, then my conclusion is 18 is also a rational number, and it is a valid conclusion. Even though that one's written a little different because we have whole number and then we have to look at the number 18, you still have to see if it makes P true. Well, 18 is a whole number, so it works. It is also a rational number. Please bring your notes and any questions you have to class tomorrow. I look forward to seeing you then.